Okay, in this example, we're going to look at a function with a rational exponent. And again, we are going to find the intervals where the graph of the function is concave up, where it's concave down, and also where there are any inflection points. All right, so we're going to go ahead. Since we're dealing with concavity, I need to get to the second derivative. So my first derivative, I'm going to take the derivative of 5, constant is 0, okay, minus, I bring down my exponent, 4/3, and then I take x to the 4/3 minus 1. Okay. Now remember, when I take 4/3 minus 1, that is the same thing as 4/3 minus 3/3. So what I wind up with is my first derivative is equal to negative 4/3 x to the 1/3. Okay. All right. Now I got to take the second derivative. So, and I take the second derivative, x, I have negative 4/3 times, I bring down my exponent, so 1/3 times x to the 1/3 minus 1, but remember 1 is just 3/3, so this is equal to negative 2/3. Okay, so what I'm going to go ahead and do in writing this second derivative down, okay, is that it's all of a sudden my second derivative has turned into a rational function in this case. So in the numerator, I have negative 4, and in the denominator, I have 3 times 3, which is 9, and then I have x to the negative 2/3, so that means I've got to put that in the denominator as well, so x to the 2/3. There's my second derivative. Okay, so remember to find my partition numbers or my critical values, okay, I need to see where the second derivative is equal to 0. And remember that when I have a fraction, the second derivative is going to be equal to 0 when the numerator is equal to 0. So that means I have to find a case where negative 4 equals 0. That doesn't happen, okay? So there are no places where the second derivative is equal to 0. The other thing I look for is places where the second derivative is undefined. Those are places where the denominator is equal to 0. So I have 9x to the 2/3 is equal to 0. If I divide both sides by 9, I've got x to the 2/3 is equal to 0. Well, the only thing I can raise to any exponent and get 0 is 0. So x equals 0 is where my second derivative is undefined. Okay, so the question is x equals 0 in the domain of my original function? And the answer is yes. I can plug 0 into f of x because 5 minus 0 to the 4/3 is just 5 minus 0, which is 5. So this is a critical value because 0 is in the domain of f of x. So remember, in determining if something is a critical value, we have to go back to the original function. As long as it's part of the domain of the original function, then that x value is a critical value, whether or not it's undefined in the first derivative or the second derivative. All right, so now that we've established where a critical value is, and I only have one of them, so for my sign chart, I just have to put in one value, that's x is equal to 0, okay? And I'm going to pick a spot to the left. So I'm going to pick negative 1 on the left, I'm going to pick a positive 1 on the right, and I'm going to go ahead and put these values into my second derivative. So the second derivative of my function at negative 1 is going to be negative 4 over 9 times negative 1 to the 2/3. Okay. Well, when I do that, when I take negative 1 and I square it, that becomes a positive 1. And I take the cube root, that's going to be a positive 1 as well. So this is going to be equal to -4/9. That is less than 0. So I am concave down on the left side of my critical value here. Oh, and I just realized I forgot to fill in the circle on my critical value. There we go. That's better. Okay, now I'm going to evaluate my second derivative at 1. So this is going to be -4/9 times 1 to the 2/3, which again is -4/9. And this is also less than 0. So my second derivative is negative on the other side, on the right side in my second interval. So for my answers, where am I concave? Where am I concave up? I'm not concave up anywhere. So that's NA. Okay. Where am I concave down? Well, I'm concave down from -infinity to 0, and then again from 0 to infinity. Okay. And as far as inflection points go, notice right here, okay, my second derivative doesn't change sign. Doesn't change its sign. So it can't be an inflection point. So there are no inflection points. And that's our solution.